Hello everyone. In the last lecture, we have finished our discussion on the neutron logging tool and I gave you a brief introduction of sonic or acoustic porosity logging tool. So before we go into the details of sound or sound waves or acoustic waves and the acoustic logging and the porosity measurement from the acoustic logging tool, and before we discuss the different application of our acoustic logging tool, it is very important to understand the basic concept of elasticity, because elasticity forms the foundation of many of the principle of our acoustic logging tool. So it will be very useful if I give you a very brief review of the basic concept of elasticity and the elastic properties of different materials. If you are not already familiar with that, it will be helpful for you to understand the basic concept of our acoustic logging tool. So many of you may not have gone through the mechanics of solid or strength of material course. So I will give you a very brief introduction of stress strain relationship and the concept of elasticity and the different modulus of our elasticity. So elasticity refers to the ability of material to deform when subjected to an external force and then return back to its original shape once the force is removed. So if the material have elastic properties and if you apply any force on it, it can deform, and once the force is removed, the material can come back to its original position. So we can say that a material can stretch and then come back to its original position if we are working within the limits of elasticity. So this property plays a very crucial role in understanding how sound wave travel through the different medium. So velocity of sound waves or acoustic wave in any medium, whether liquid, solid or air, it depends upon the elastic and physical property of that medium through which the sound wave is traveling. So let us say you have a rubber band, and if you stretch it, it is going to elongate, and when you release it, it is going to go back to its original position. So this behavior is due to the elastic property of the rubber. So if a material possesses such property, then only it will be able to propagate the sound wave. Even the steel or hard dense medium also possess that the property of elasticity. So in the context of sound wave or acoustic properties of any material, elasticity plays a vital role in how sound wave is going to propagate through different medium. So whether the velocity of sound wave will be low or high, it will depend upon the elastic property of the medium as well as the physical properties such as density of the medium. Sound wave can only travel in elastic medium. In fact, sound wave will require the elastic medium to travel because the sound wave is made of vibration, and the vibration can only travel through any medium if the metal is elastic. So when a sound wave is generated, so first, what is a sound wave? The sound wave or sound is a form of energy that travel through a medium in the form of waves. For example, sound waves are created or the sound energy is created when an object vibrates. So when an object vibrates, it creates a sound. For example, you might be familiar with the guitar. So how do you play the guitar? You create disturbance in the guitar strings. So when you create disturbance in the guitar string, it starts to vibrate. So this vibration created by the guitar string creates a sound wave. So how does this vibration created by the guitar string travel through the different medium? So whatever that vibration that you have created, it is going to create disturbance in the surrounding medium, or the, in this case, the surrounding air particle. So this disturbance or the vibration causes the molecules or the particle in the material or in the air to move. So the generated vibration may cause the air particle to move in a pattern of compression or rarefaction, or it may cause them to move back and forth. So this movement of air particle allow the propagation of our sound energy created by the guitar string. So we can say that when these vibrations are created, these vibrations start to deform our air particle or the medium which is made of air. So because of the elastic property of this medium, or in this case air, the particles can move back and forth and then they come back to its original position. So this way the air particle will allow the movement of vibration created by the sound. So this movement of particle is what we perceive as sound. So elastic properties or elasticity of the material is what enables these molecules or the air particle to move back and forth around their equilibrium position, allowing the sound wave to travel. If these particles cannot move back and forth and they cannot come back to its original position, the sound cannot travel through this medium. So understanding the concept of elasticity help us predict how sound wave will behave in different medium, how they will interact with different material, and how they will reflect or refract as they encounter different boundary. For example, when the sound wave is going from one medium to another medium, such as from liquid to solid or one type of solid to another type of solid, how the sound wave is going to behave when they encounter boundaries, that is going to be defined by the our elastic properties of the different materials or different medium. So this knowledge is very essential for grasping the fundamental of our acoustic logging tool. So I will just give you a very brief of basics of our elastic properties of the medium and how sound wave can propagate in one medium and how they are going to behave when they are going from one medium to another medium. After that, you will be able to understand how the acoustic logging tool works in our wellbore. So let's start today's lecture. So these are the topics that we are going to cover today. The basic concept of elasticity, different type of elastic constant or the modulus of our elasticities, and introduction to elastic body waves. So what is elasticity? So elastic properties of the rock, it defines the ability of any material or the body to resist the permanent deformation when an external force is applied. So if you have an elastic body and if you apply a force to it, it is going to deform. But the moment you are going to remove the force, the material will come back to its original position only if you are working within the limit of its elasticity. So elasticity defines the relationship between the external forces applied on the body and the resulting change in the shape and size. So how much size, such as its length, is going to change of an elastic body when an external force is applied to it can be calculated or defined by the elasticity of the material. So let us first understand what is stress and strain. So stress is defined as sigma is equal to F by A, where F is the force acting on the cross-sectional area A. So whatever the force that you are acting on any body which is trying to deform the material divided by the area against which the force is acting is calculated as stress acting on the body. So we can have a tensile stress or the compressional stress or the shear stress. So a tensile stress is caused by an applied load on force which is trying to elongate the body of the material. Whereas the compressional stress, it is it is caused by the applied load of the force which is try to compress the body of the material. That means a tensile strength will try to increase the length of the body and a compressional stress will try to decrease the length of the body. So in this case the length will increase, in this case the length will decrease. Whereas if a shear stress is applied, like in this case tensile and compressional stress, the force is acting here, we are trying to pull the body apart. The force is acting here, we are trying to pull the body apart. And here the force is acting here and we are trying to compress the body. Whereas a shear stress is where the force is or the load is applied tangentially to the body, and it makes the material or the different part of the material to slide over each other. So when the force is applied in such a way that the different part of the body are moving on each other. So this load will force the material or the body of the material or different part of the material to slide over each other. So this way the body of the material can be deformed by applying a tensile stress or a compressional stress or a shear stress. So what is the change or the result by applying these stresses? As I mentioned that these forces are trying to deform the body of the material. So a strain is going to develop. So a strain is nothing but deformation and displacement which occurs due to the application of stress. So when we apply any stress, it is going to deform the body of the material. So this deformation is measured in terms of strain. For example, so when you apply a tensile stress, we have a transverse strain, and when you apply a compressional stress, we have a longitudinal strain. So what are they measuring? They are trying to measure the how much deformation has happened. So this transverse strain epsilon et is defined as by change in length divided by the original length, and this el epsilon el is defined as the change in diameter divided by the original diameter. So what is happening? You applied load or force which caused the change in the body of the material or its dimension, and this change or deformation of the body of the material is defined by the strain. So we have a transverse strain in tensile stress and longitudinal strain in case of compressional stress. Same way, when a shear stress is applied, we will have what? Shear strain. So you can see here a force is applied tangentially, and it is trying to force the different part of the metal body to slide over each other. So it will deform parallel to the force or load applied. So for example, you can see here this was my original position and this is my new position. So this much deformation has happened. So again the same way I can define the shear strain as epsilon. What is the change in length? Delta L divided by L naught. So this is my displacement which have occurred divided by original length, or this will be equal to the, if theta is the angle of deformation, then tan theta. If theta is very small, I can write this simply as theta. So this is what stress or strain and how they are defined. Now these stress and strain are defined by the elastic properties of a material. So which is defined as the by the Hooke's law of elasticity. So Hooke's laws of elasticities, it states that for a relatively small deformation of an object, the displacement or size of the deformation is directly proportional to the deforming force or load. And under these conditions, the object is going to return to its original shape and size upon removal of the load. That means when a stress is applied, so how much deformation is going to happen? It will depend upon how much force or load or stress is applied on the body. If you are going to apply more load, you will have more deformation. If you apply less load, you will have less deformation. And if the body is behaving elastically, then when you remove the load or the force, the body will come back to its original position or original shape and size. So we can have two type of deformation. One is the elastic deformation and second is the plastic deformation. When we have elastic deformation, so for example here we have what? Stress on y-axis and strain on x-axis. So in the limit of elastic deformation from here to here, when you are increasing the stress values, your strain value is also increasing. And let's say I have applied this much stress, so this much strain has happened. So this is my stress applied, and this is my strain in the body. So if I remove the stress, so again the strain will go back to 0. So in elastic deformation, the body is deformed only when you are applying the stress or the load. The moment you are going to remove the stress or the load, the deformation will be gone and the body will come back to its original position. Whereas in the plastic deformation, which is the opposite of our elastic deformation, so this is defined by the unrecoverable strain. So the deformation in plastic deformation is retained after the release of applied stress or load. So this elastic properties of a medium is very much important to understand how a sound wave can travel through the or a particular medium. So this elastic deformation in the elastic limit of the body can be defined by the different modulus of elasticity. So different modulus of elasticity can be used to determine the this stress and strain relationship in the linear elastic portion of the stress and strain curve. So for example, we can define the Young modulus of elasticity. So Young modulus of elasticity is the elastic modulus for tensile and the compressive stress when the stress is applied in the linear elastic regime or where the elastic deformation occur. So accordingly, we can define stress and strain relationship as stress is related to our strain as stress is equal to E, where E is the Young modulus of elasticity multiplied by the strain. So this Young modulus of elasticity is nothing but ratio of stress to strain. So what is my stress? It is force divided by area. And what is my strain? How much deformation in the length divided by the original length. So this way you can see the strain is which is developed in the body is related to the our applied stress. So strain is equal to whatever the stress applied on the body divided by the Young modulus of elasticity. So if a body have very high Young modulus, that means the strain developed in the body will be less. For example, if you have a rubber or rubber like material, and if you have a, let's say, wire or metal wire, if you apply a small force which is similar on both rubber and metal wire, the rubber body will be elongated by a large amount, but the metal wire will only elongate by a small amount. This is because the modulus of velocity or the Young modulus of elasticity of the rubber and metal wire are different. So how much strain will be developed inside a body, that will depend upon the our Young modulus of elasticity. Similarly, we can also define the shear modulus of elasticity. So shear modulus of elasticity will define how resistant a material is to shear stress. Same way, the Young modulus of elasticity defines the how resistant a material is to applied tensile or compressional stress. So the shear modulus will be used in case a shear stress is applied on the body to describe the material response to the our shear stress. So the same way it can also be calculated as G is equal to shear stress divided by the shear strain, that is equal to force by area divided by the our deformation, which will be theta if the angle of deformation is very small. We can also define a bulk modulus of elasticity. So a bulk modulus of elasticity describes the volumetric elasticity or the tendency of an object to deform in all direction when uniformly loaded in all direction. So this is defined as K is equal to minus of delta P divided by delta V by V. So where delta P is the change of pressure or force applied per unit area of the material, delta V is the change of the volume of the material due to compression, and V is the initial volume of a material. So for example, if we have bodies submerged inside the water, the forces are applying on the body of water from all direction. So how the volume of the body is going to change when the forces are applied from all the direction, that is controlled by the bulk modulus of elasticity. So let us take another example. Let's say we have a rubber ball and we have a metal ball. If you squeeze both the ball by your hand with the same force, what will happen? The rubber ball will be squeezed more compared to the metal ball, because the modulus or the bulk modulus of elasticity, which controls the delta P or the force and the volumetric strain, are related by the bulk modulus of elasticity. So because the rubber ball have different bulk modulus of elasticity and the steel ball have different bulk modulus of elasticity, the change in volume of a rubber ball and the metal ball will be different. Now, what is Poisson ratio? So a Poisson ratio is defined as the negative ratio of the transverse strain to the longitudinal strain. So it is simply defined as the mu as minus of epsilon et divided by epsilon L. So this way these two strain are related with the help of Poisson ratio. Also the different modulus of elasticity such as the Young modulus, shear modulus and the bulk modulus of elasticity are related with each other by the help of Poisson ratio according to these equations. So we can compute the different modulus of elasticity if we have the Poisson ratio values according to these equations. So these were the basic concept of elasticity, what is an elastic deformation and what are the different modulus of elasticity and how this modulus of elasticity control the strain or the deformation which is going to occur if we apply different types of stress. So let us now start discussion on the sound propagation. So let us first discuss the different types of waves. So as we have discussed in the start, the waves or the sound wave are going to propagate when the vibration are created, and these vibrations are propagated by the sounding particle or the particles of the medium in which the sound wave is traveling. So the velocity of sound wave in acoustic wave logging in the formation depends upon the elastic properties and the density of the material it is traveling through. So as you can see in this animation, you can see the particles of these mediums are moving when a sound wave is originated, and this way the acoustic energy is propagated. So how does the elasticity or the density of the material help us understand the propagation of wave? So for example, we know that the vibrations are forcing the our particle or the molecules of the medium to move back and forth to allow the movement of our sound wave. So if a medium have very high elastic properties, so what happens when you are generating a sound wave, you are creating deformation. So if I'm trying to send a sound wave inside the, let's say, earth formation, okay, so the moment the vibration of the sound waves strikes the my earth surface, it is going to deform the earth body. So if the earth body is elastic, so the deformation will happen and the particle of the earth body can come back to its original position quickly if the earth body possesses our elastic properties. So deformation is going to happen when the sound wave is originated in any medium. Now it will depend upon the elastic property of the medium. So if the elastic property of the mediums are very good or this medium have very high elastic properties, the deformation will happen, but the particle of the medium can come back to its original position quickly once the deformation is or once the force causing the deformation is removed. So the particle will be ready again to transfer the acoustic energy. Whereas if the medium or the earth body have very less elastic properties, the particle of the medium will take larger time to come back to its original position, and it will take large time for the body to propagate sound. So for example, let us compare the steel and rubber again. So steel have very high elastic properties. So strain which is developed inside the steel when a force is applied, it's very small. Whereas if you apply the same force on a rubber body, a large strain will develop. So it will take the time in a rubber body to come back to its original shape. Whereas in steel, where the strain is very small, when the force is removed, the particle of the steel body can come back to its original position very quickly. So the disturbance that you are seeing, how long it will take this medium, this body to come back to its original shape, it will depend upon the elastic property of this medium. So the modulus of elasticity, whether elastic modulus or the Young modulus or the bulk modulus, depending upon the type of wave, will control how fast a sound wave can travel through its medium. Whereas the density of the medium can also control the how a sound wave can propagate through a medium. For example, if you have a denser material, so where the density of the material is very high, there the molecule will have very high mass or the particle will have very high mass and they will be of larger size. So for sound wave or the vibration created by sound wave, it will not be easy to move them if the particles or the molecules are of bigger size. So generally, if the density of the medium is high, the velocity of sound wave will be low because it will take large energy by the sound wave to move these heavier molecules or the medium or the particles inside the medium. So this way, elastic properties and density of the medium can control our propagation of sound. So again, to summarize, in this figure, you can see, you can visualize when a vibration is created, okay, when a sound wave is generated here, it is deforming this body or this medium, and the particles are deformed. The moment the force causing the deformation is removed, it will come back to its original position, and if further vibration is created, it will again deform, and this way it will propagate the acoustic energy or the sound wave. So elastic energy can propagate through in earth in different ways and at different speeds. For example, generally we have mainly two types of waves or sound wave inside our earth medium, which are body waves and surface wave. So body wave again can be of two types such as P wave and S wave, and surface waves can be of two types, Rayleigh waves and the Love wave. So a body wave is a wave which travels through the medium, and a surface wave is a wave or a sound wave which travels along the surfaces and the interfaces. So today I have given you a very brief introduction of elastic properties of the medium and a very brief introduction of how a sound wave can travel through a medium. In the next lecture, we will discuss the different type of sound wave or at least the different types of sound wave which we can encounter in the acoustic logging inside our whalebone. Thereafter, we will discuss the how this sound wave can be characterized to get an idea about the porosity of the formation. I hope this basic revision of elasticity of the medium is helpful enough for you to understand the propagation of sound wave inside different medium. If you want more clarity on the different concept of elasticity, you can refer to a different books where the strength of the material is discussed, or you can also browse to different sources on the internet. There are a number of good sources available on the internet which can guide you through the elastic properties of the medium. See you in the next lecture.